Hi guys, welcome to this video. So today we will solve one more Geek for Geek questions. This is the smallest positive missing number. This comes under medium. Okay, so let's get started. The question is, you are given an array of any integer. The task is to find the uh, smallest positive number missing from an array. So here the note has been given that the number starts from 1. So we need to find out the smallest positive missing number which is after 1, like whether it is 1, 2, 3 or 4. Okay, so let's understand the example. So in the example 1, they have given n is equal to 5, and if you see 1, 2, 3, 4, 5, so from 1 to 5 it is present. So what number is missing? So that is the 6. The 6 will be the smallest positive number. Okay, it is justified. Now let's look into the second example. So here they have given 0, minus 10, 1, 3 and 20. So by looking at the second example, you can make out like we will not have the shorted array, or we will not have only the positive numbers, right? We can have any kinds of like any kinds of whole numbers including negatives. Now if you will check over here, 1 is present. No, no, no. Yeah, 1 is present. So let's check for 2. Is 2 is present? No. So 2 is the smallest positive number. Okay, now we will check the expectation. The good expectation is to have a complexity of O of n, and the space is like O of 1. Okay, we'll discuss about this. And another constraint is like your n can be from 1 to 10 to the power 6, and the value of all the numbers inside the array will be from minus 10 to the power 6 to uh, positive 10 to the power 6. Okay, so why I told you to look into this constraint or the expectation, because this problem seems very easy when you have hash set or hash map. You can just put the numbers and check whether 1 is present or not, 2 is present or not, 3 is present or is not. So you can check like that as well. So that is one of the way you can solve this question. But even though you will get the time complexity of O of n, but the space complexity remain that case. Okay, what we are going to do, we are going to play around, we need to think about how we can solve this into this given constraint. So let's understand what can be the thought process and how we can solve it. Okay, now let's understand this question with an example. Suppose I am given an array, so 3, 4, minus 1, 1. Okay, so what we will do here, we are having indexes 0, 1, 2, 3. So whenever you get any questions which is based out of indexes like 1, 2, 3, 4, which is in like series of numbers, especially with 1 to n, you need to make sure that you need to play with the indexes. Okay, because indexes will not be greater than the size of your what you call size of your array, right? It will be always 0 to n minus 1, and here they are asking for from 1 to n, right? So you need to make that analogy that you can play around, you can run your thought process in that direction so that you come up with any solution. Okay, so in this what we are going to do, so whatever the number is present right now over here, we will check if with this number it is present in certain index or not. How we are going to check? Suppose this is my I, this is my number. So what will be the index? We will check n minus 1. Okay, 3 minus 1, that is equal to 2. We will check is it present at the index 2, which is no, right? It is present in index 0. So what we will do, we will swap with the index 2. So now our array will become 3 and 1, right? So this will become my indexes. Now we will stay here only. Now we will check is it greater than 0? No, right? Even if I'll do minus 1, minus 1, it will become minus 2. So let's move on. So we will come over here. Okay, now we'll check if 4 minus 1, that is 3, is it present at the index 3, which is not the case, right? But we do have index 3, so we will swap with this. Okay, now our new will 4. Okay, now we will stay here. Okay, so now we will check 1 minus 1 0. Is it present at index 0? No, it is at 1. 0 1 2 3. So now we will swap it 0. Okay, so now what will remain will become positive 1. Okay, now it will become minus 1. Okay, and 3 4. Now again we will check for minus 1. Is it present at this index? No, right? So we'll move to this index. Let me erase this part. Okay, so now we will check here. If 3 minus 2 is equal to 2, is it present at index 2? Which is 2 is correct. We will move to next. Now we will check if 4 minus 3 is present at index 3. Yes, it is at present at index 3. So now we are done, right? Now what we will do, we will traverse through the indexes again. Okay, we will try and we will check if any of the number which is not it at appropriate index, that is the number we are going to return. So 1 is at appropriate index, 1 minus 1 0. Now this minus 1 is not at appropriate index, 1. So our number will be this index plus 1, which is 2. Okay, so we will write the code for the same. So now we have understood the thought process or how can we solve it. So let's code for that particular thing. So what we need to do, we need to play around the indexes like I told. So we will traverse the index I less than n, I plus plus. So now we will check for correct index. Correct index is AR of I minus 1. Now we'll check if my correct index, like you checked, right? The normal indexes is from 0 to n. So we will check the correct indexes also, because there are negative numbers as well in the indexes. If it is a negative number, it will give array out of bound exception. So we need to check all those things, if it is greater than 0 and if it is less than n. And we will check if error of correct index not equal to error of I. So now you need to pay attention that it is a while loop and not a if loop. Okay, not a if condition. So while loop, it will run till your first index, that is the I, is not at proper place, or it cannot be at the proper place if it is negative or something. If it is out of life, like if I'm having 1000, okay, so it is out of my index value. Suppose my n is 5 and the number is 10 or 11. So till it is outside of my range, or it is not a proper number which can be under that range, so till that point of time we need to run that value. So what we need to do, we need to swap in this case. So what we will swap, we will pass an array, so the correct index and I. Okay, these two will swap. And now the correct index, we need to make sure, again we need to do till we have this as equal. Okay, so my correct index remains like this. Okay, till my first value becomes equal to the correct index, we're going to do that. Okay, now once I'm done with my this loop, now what we need to write, we will write the same loop, and we will check if my all the numbers are at proper place. Okay, if any of it is not at proper place, then we will return the index plus 1 of that value as discussed, right? We will check if error of I not equal to error of I minus 1. It is not equal to I, then we will return I plus 1. And suppose in these case, like if my all the numbers are at proper index, like 0 minus 1, everything is a proper index. So now in those cases we need to return n plus 1. Now I have written a shortcut like swap method, so that this method we need to write. So we'll write static void swap. So we are going to pass array and the indexes. Suppose index 1 I in j I'm writing over here. So I'll just take a temp value and I'll put the j value, okay. So let's compile this. Okay, you need to have return type. So it compiled successfully. Let's submit it. Okay, that's it for this video. See you in the next. Thank you.